Hey guys, today we're going to be talking about recursive calls, and to help us understand this a little bit better, we're going to do two examples, one with calculating factorials and another one with calculating Fibonacci numbers. So, two things to always remember whenever we're talking about recursive calls. First thing to consider is what is our base case, and our second thing is what are the rules that we need to apply to reduce to this base case. So we're going to use an example with factorials, but before we do that, I just want to give kind of a visual example of representation rather of what is happening when you're doing recursion. So if you'll remember, we have our stack and our heap here, and whenever we run any program in C++, first thing that's going to pop on is our main function. Now we're going to assume a very simple program here. The only thing that's in it is this recursive function, and so it's going to call that recursive function. Now this function is going to go ahead and call itself, and it's going to do it again until it finally reaches a base case. And once it reaches the base case, then the function is going to exit, and then each successive call is then going to exit. Now you might have a situation that before all the calls are popped off, that it actually calls itself again, and this would be in the case of a particularly complicated recursive call. Even so, eventually you want to reach your base case, and then all the functions will they'll all pop off. So that's just kind of a visual representation of what happens whenever you're using recursion. Let's go ahead and move back over to our code. Alright, so before we even look at any code, let's go ahead and establish what our base case is going to be and figure out what rules we can apply to reduce to this case. So here I have our factorial sequence in general form. We have n times n minus 1 times n minus 2 all the way down to 1. And then here for our specific example, we have 5 factorial equals 5 times 4 times 3 times 2 times 1 times 1. And the reason I have 1 second time is just a reminder, so we do have to deal with a case. 0 factorial will be equal to 1, and so we should need to make sure that we don't forget about that case there. So what we're going to have happen is that we're going to be passing in some function that we want the factorial of, and in this case that's 5 here. And so what we want to do is multiply that number times that number minus 1 times that number minus 2. And so what we can do, you can kind of see the thought process here, is that each time we call the function, we want to have it multiply itself by the function, then we want to call the function again. But what we want to pass in the second time is n minus 1, and then n minus 2, and so on and so forth. So with that said, let's go ahead and look at the code that we have here. So we have this function here, it's an integer, and you can see down here we've set it equal. Almost always when you have recursion, you're going to be returning something. That's just usually the situation. Alright, so we've got our factorial function, we're passing in the factorial, and we're saying if factorial equals 0, then return 1. So this is our base case here, we've kind of handled that. And now we've got is factorial equals factorial times, and then we're calling the function again, and just like we said before, we want to went ahead and go pass in n minus 1. And then what's going to happen is that this is now going to be n minus 1. It's going to go through here. Hopefully we'll assume it's not 0 yet. And then it's going to go down here and it's going to say, okay, well this equals myself, so n minus 1 times, and then call the function again. So n minus 2. And you can kind of see that, okay, well we started with n, now we have n minus 1, n minus 2. And then what will eventually happen is that we'll call this function, and we're iterating down 1 each time, so our factorial will eventually equal 0. And so we'll return 1. And so what will happen here is this will be 1, and then this, we know that the factorial here, this has to be 1 itself, so then 1 times 1, and then what will happen is, so that'll return, and then we'll have here 1 times 2, and etc. And you can kind of see how that ends up being our sequence here. 1 times 2 times 3, etc. all the way up to our number here. And I wrote this out in 2 lines. You actually don't need to. Just if you wanted, you could do just like this, and this actually works just fine. This is a little bit maybe looks confusing, so that's why I didn't do this at first. But just so you can see what happens here, when you call this return statement, it says, okay, well, what am I returning? And you said, okay, well, I want to return factorial times, and then I want to call this function again. And now it needs a number here, so it has to enter that function and try and come out with a number. And it does that recursively, of course, all the way down to the first case. And then you get 1 times 1, and then 1 times 2, etc., etc. And it eventually returns out. So It's kind of confusing because, we always think left or right, and we think, oh, we see a return statement here. But no, it does actually go ahead and execute the rest of this line before it exits out. So that's it for factorial function. Oh, and I guess I should probably build and run this once just so you can see that, okay, we've got 5 factorial, and it does indeed equal 120. So cool. That's it. We'll see you next video.